All right. Well, welcome everybody to day number 2 of You Gotta Love Front End. I'm very happy to be here, and thank you for coming to my talk. My name is John, and I'm from Intuit. And originally, I was an investment guy. I wasn't a tech guy. I worked as an investment analyst for a little while. I decided that the technology that we use, the software that we used for investments was way more fun. So I went back to school, studied a little bit of computer science, came out. I got a job as a web engineer in a small startup in Tel Aviv. And then I moved on to Intuit, which is a financial technology company, a financial software company. So I'm happily exactly where I want to be. Great. So Intuit offers a lot of products for people who are trying to manage their finances, whether you're a person, an individual, a family, or you're a small business or a self-employed company. And then we have lots of products, and I'm happy to help people manage their finances better as a web engineer and creating awesome experiences that make it easy for them to manage their finances. Anyway, so what are we going to talk about? Quickly, the what? TypeScript and existing JavaScript. That's 0 because of obvious reasons. No, it's not. It's just I'm not going to touch too much on that. That's what we're talking about. And the why. Why is this an important thing? Because we have to stop thinking that JavaScript and TypeScript are enemies. They're actually a story of coexistence, and hopefully I'll be able to convince you to that. The who. Metallica fans? Anyone? Nice. Not enough, but okay. Who is this going to help? Who is this ultimately for? Why can TypeScript help solve some problems for some people? And the where. Where are we going to start attacking this subject in our projects? And then the how. All right, so let's get started. The why. Let's end these religious wars for once and for all. A show of hands, please. Who has tried TypeScript? That's actually a very good amount. Have you used it in production? Have you pushed it to production? Nice. Who has had a negative experience? I also had some negative experience. Who had positive experience? Awesome. This is a very good crowd. Now, let's get a few things straight here. This is a graph. Maybe it's a bit too small for the people at the back, but this is a GitHub graph on the most popular languages per project, and I'll zoom in to the top right, and JavaScript is right there. It is the most popular language on GitHub right now, but TypeScript is very close to it. It's right up there with Go. In fact, it's a bit more popular than Go, and this is not to be overlooked. I understand that our keynote speaker, Kyle Simpson, made a few good points yesterday, saying maybe TypeScript does not solve his problems in the way he wants them solved. And I can respect that. I get that. But this cannot be overlooked. This is a lot of popularity. This is a lot of demand. This might mean something, because I don't know if you guys saw in his talk yesterday, in his slides, he showed a snippet of what ES4 would have looked like. ES4 never made it to production, but it kind of looks like TypeScript because it's like a strongly typed version. So ES4, I read somewhere, that never made it to the standards because Microsoft was kind of being pushy about it, and some other people didn't like it, and in the end TypeScript made its own ES4 into the TypeScript project. So now we have it and we can use it, and it's very popular. And just a note on that, if you know TypeScript, you know JavaScript. Don't pretend that TypeScript and JavaScript are completely different languages. They are the same language. If you know TypeScript, you should know JavaScript. Don't think of it as a completely new language. And if you know JavaScript, you know TypeScript. You're just a bit rusty. All right? The learning curve is very small. Now, you wrote some JavaScript code and walks into a bar, whatever, and at the back sits this error. Who's had this error before? Or the other one, some object.getID is not a function. Yeah, okay, that's a very good amount. So, it's strong, but it's not a JEDI yet. So, Are JavaScript and TypeScript friends? Are they enemies? Are they frenemies? No, they're friends. TypeScript is like a toolkit for JavaScript. It's some sort of a superset. They market themselves as a superset of JavaScript. It's a guardian or a champion. It's an add-on. It's something that helps you write better JavaScript, right? Kind of looks like that. Nobody messes with that. You know what I mean? By the way, who's excited for the new season? I can't wait. Did you guys see Jimmy Fallon? Arya said something, yeah? The April Fool's joke? Okay, great. Game of Thrones. Right. Okay, anyway, JavaScript and TypeScript are a story of coexistence. They're not a separation. They should be used together until TC39, or the ECMAScript Council, accepts that strongly typing is an option for ECMAScript. They should be used together. Cool? Cool. Now, let's talk about the who. Who is this going to help? How can TypeScript help improve existing JavaScript code? Now, obviously, it's going to help our customers, right? Because we have type safety, probably better code in production. But the customer doesn't care. They're not going to use your app more because you use TypeScript in it. They don't even know, right? But more importantly, it's important for the team. TypeScript is an automatic boost in documentation, isn't it? It helps you design your code better. And it is a definition, API definition for your entire project. Now, I'm going to show you a little code snippet a little later. Actually, let's jump to that. All right. This is something that we're working on right now. My team and I, and half of my team is here. We're working on this, and think about a function called submit bank payment, right? And here are the parameters, bank details and invoice details and some configurations. I don't know. Oh, here we go. Configurations and some options. Now, we started getting lots of production errors about like the bank object is not correct in all cases. Why? Because bank payments are done, like we're writing this code, but other client teams might be using our code and passing their own variables, own parameters into this. So now, let's say you're the new employee, the new engineer, and you have to come in and write this function, is valid bank details, or the is valid invoice details. How are you even supposed to know what a bank object should look like? Like, how are you even supposed to know that's what it's supposed to be? Because I know an invoice looks like that. It's a huge object with lots of keys and values. Some of them, I remember when I first started into it, we were working with bills and receipts. And there is a connection. For example, every bill has multiple receipts. There's an association that comes from the back end. But when I tried to write a TypeScript definition for it, it was huge. It was such a big learning curve. And I said, how did the last team work on this? Well, because they wrote the server side and the client side. They know exactly what the object looks like. They know the schema. So it was easy for them. But what about the new guy? What about the other team that's going to take over your project? And in large organizations, this is a very typical story. You don't always end up at the same team that you're working on, and the same project that you're working on. You hire new engineers. You hire junior engineers who may not have the sort of the production experience that you've had, right? So always think of the new guy. Am I clear on this? Like, it's so important to be able to release. Think about the situation where your server team produces type definitions for what an invoice or a bank account looks like. That's the dream. Then the client-side engineer can take those type definitions and plug them into the project and work with them. Now you know exactly what a schema looks like, what the bank or invoice schema looks like. All right. So now, where do we start attacking this? All right. So there are lots of opinions on how should we start writing TypeScript. I know a lot of teams that are trying to convert their entire projects to TypeScript, and that requires major refactoring. And sometimes it's not easy to do. Sometimes it's not good to do. All right? Let's pick a good spot to enter and then start from there. Let me give you an example. Think about let's say a React project, hypothetical React project, where you have three React components. These are the ones that are facing the user, like the most out-facing components. And they depend on some shared component. They can be extending this class. They could be using this class as a higher order component. And this shared component utilizes some module that you wrote, maybe some logic code or some functional, some pure functions that run some logic, and an NPM library. Maybe this is a bit abstract, so let me sort of take this down to the real world. This is what I'm working on right now. This is a bank form for the user, all right? As you can see, every single input has some sort of a label, and it has an input field, right? So it's very typical for teams like us to sort of like have one reused component called like a labeled input, and then the routing number component will extend that. So will the account number component, right? And I'll add a little twist to this. They also have to make sure that validations are done correctly. And we're not using standard HTML validations. We're using our custom validations because of styling reasons or logic. All right, so what would that chart look like? We have 3 components: account number, routing number, and account holder's name. And they all extend to this class called validated labeled input. And the validated labeled input depends on maybe show error. It's a utility function that we wrote, and it's going to determine whether this current input value is validated correctly or whether it's wrong, and what kind of message to show, and it's internationalized. And we're using an NPM called validation, some bank validation NPM. It doesn't matter, it's hypothetical. So let's go back to the original chart. This is what a very typical React component looks like, at least ours, the validated labeled input, right? So where do we start attacking? Which one do we convert to TypeScript first? Always start at the deep end of the dependency graph. The code that has the most clients, or the code that is reused the most, should be converted first. All right? So phase 1, the utility module and the NPM library. If you start here, then you're going to see a huge boost in your type safety. And it's going to be easier to convert the next phase. And the next phase is the shared component. Now the shared component can utilize the type safety that it depends on, for code that it depends on. For example, the utility module and the NPM library. Now it's easier to convert the shared component, which is the validated labeled input, into TypeScript. And after that, maybe to convert the most outward facing components to TypeScript. You don't have to. It's maybe because it doesn't have clients, it's easy enough, right? JavaScript and TypeScript can coexist, remember? Don't let your OCD take over and convert everything to TypeScript. You do not have to. In fact, I'm going to make another claim. I prefer, and I urge, that you don't write unit tests in TypeScript. Because let's say I have my utility module, right? This utility module is a pure function, doesn't have any side effects. It takes some values and it spits out some validation error. This routing number is invalid or something like that, right? Now, what if this utility module gets reused by another team? They don't know what the function signature. What if they send a null, right? I want to unit test that. What if I send a null into this function? Does it behave correctly? Well, TypeScript unit tests will never let you pass null into that function unless you start doing as any. You guys know what I'm talking about, right? So that's not useful. I'm urging you to write unit tests in JavaScript because it's like a dumber version of user using that function or whatever it is that you're testing. So I urge you guys not to convert everything to TypeScript. All right? I know it's not a very TypeScript-y thing to say, but like I urge you guys to remember, we are JavaScript. If we start moving away from JavaScript, if one day TypeScript team decides that they're not following the ECMAScript conventions, if they start releasing features that are not in JavaScript or they're never going to be in JavaScript, then maybe we go back to what Kyle Simpson is saying about how the machine JavaScript or all of these spin-offs of JavaScript are starting to diverge and we're losing our open community. I agree with him. The TypeScript team always talks about how they release ECMAScript standards a couple of weeks later in their nightly releases. This is very important. We are JavaScript, okay? We're just doing it a bit more safely. Oh, what about the NPM library? Right? Because nobody's going to go into their node modules directory and change some code into TypeScript, right? I'm sure all of you know they have TypeScript. Don't worry. Most of the NPM libraries these days are actually, they either are written in TypeScript or they provide type definition in the @types collection. All right? So this is our entry point. To recap, go at the deep end of the dependency graph, Convert those first if you'd like, and then move on to the less depending components and convert them. It gets much easier anyway. All right, the how. And I urge you guys to sort of pull out your laptops if you want and try this. If you guys have never used these things, we're going to go in phases. Phase number 1, always install the type definitions of the NPM libraries that you use. All right? If you do this, it's TypeScript enough. Trust me. And we do this in our team all the time, and it really helps us. Let me give you an example. Let's say you have a JavaScript project. Okay, and it uses React, it has React DOM, and it uses a credit card validator library called Card Validator. All right, and I believe this is important, by the way. The IDE that we're seeing here is Visual Studio Code. In Visual Studio Code, if I hover over the render function of React, it says loading. Okay, now, I don't know what the render function signature is. I know most of us know React a little bit, or Angular at least. Like Angular is written in TypeScript, so that's a different story. But we know what the React DOM render does. But take this as a point as to we don't know what the function signature is. If this wasn't React DOM, if it were a more obscure library, we wouldn't know what this function signature would look like. So, oh, by the way, this is IntelliJ. Same story in IntelliJ. It just says that it's a function. Now, let's do this. npm install save dev types of React and types of React DOM. Now what happens if I go back to my IDE? I get the function signature. And actually, I didn't even know that there is a callback as a third parameter. Did you guys know that? I didn't know that. It's like, what? Okay. Step number 2, maintain definition files. So, TypeScript in general is like TS files. Yes, you write TypeScript like that. However, you can write JavaScript like most NPM libraries do. You can write JavaScript and write a definition TypeScript file right next to it. Then you don't have to touch your JavaScript, but you can still define what the function signature or that module does, or what the schemas are, and all of that. And this will really help you because of the power of your IDE. Okay? So you write JavaScript files, you write definition files. There is no compilation, no transpilation. You're still writing good old JavaScript, but your IDE knows. Let's see an example. This is a module that I wrote called utils. As you can see, it's JavaScript, and I'm using an NPM library in here called the Card Validator. And I'm extracting some utility functions that come with this NPM, and I'm going to write my version of the validate. Okay? I want the client code to send some values to me, and I'm going to validate them, and then I'm going to figure out what was wrong with the card number or the CVV number or the expiration date, and I'm going to return internationalized error messages back to the user via a callback. All right? Now, this is what a definition file would look like. I have a function called validate. You can send an ID as a string and the value as a string, and then send a callback of type validation callback. What does that mean? I define it in line 7. It's a function that takes errors, which is of validation error array, and it doesn't return anything. It's void. It's a closure for the client code to be able to access all the validation errors or the validation error messages, which are now internationalized. And what is a validation error type? It's a string. Now, this could turn into an enum one day. It can be an object. It doesn't matter what it is, but as long as it's defined, it's good. Why? Now I go to my client code that uses this validate function, and I hover over it, and I see the exact definition of it right here. Now, I didn't use real TypeScript. I didn't convert anything. I didn't transpile or compile, but look at the power you're giving the developer. I don't know if you guys have experienced sort of like new engineers coming to your team, but it's very difficult for them to take their first task and understand exactly how the project works. They're going to try and spend a couple of weeks just trying to understand your architecture, and now you're giving them a task to do, and they don't even know the function signature. Sure, go ahead. That's a very good. I don't have this project open right now. If you're willing to try something like this, that would be great. I can share my. I'm pretty sure it will autocomplete, and if not, it'll give you like squiggly. If you make a mistake, it'll give you like a squiggly underline saying this doesn't fit. Because the IDEs are powerful enough to know type definitions and show, even if you're working on a JavaScript file. All right. Right. I had to add this. It's like magic. All right. Third level. Okay, you're sold on this. You're sold on this. It's good. TypeScript definitions are working well, but now we actually want to do some TypeScript. Okay, so the first level of sort of writing TypeScript in your project, I say go with the Babel TypeScript preset. You're writing TypeScript files, okay, and you're letting Babel transpile it, not the actual TypeScript compiler. Okay, and we'll talk about why this is a good stepping stone to moving to the TypeScript compiler. Okay, Babel TypeScript preset is relatively new, and I heard about it a few months ago, and it doesn't actually compile TypeScript. It removes TypeScript syntax, which allows the rest of the Babel transpilers to take it and put it in your bundle. So let's see this in action. First, we need to add TypeScript to the project, so npm install TypeScript. You create a tsconfig file, all right, by running this command. And the tsconfig file, I'm not going to go over this. It's basically a bunch of configurations for your TypeScript compiler to look at your project, how to perceive your project. It has some configurations on compilation. You can specify what kind of target you want it to be. If you know you have to be backwards compatible, you might want to choose target as ES5 and things like that. Which files to include, which files to exclude, like node modules, and how to deal with existing JavaScript in your project. It's actually pretty handy. And it also lets you do experimental TypeScript features such as decorators. All right? So we've created a TypeScript configuration file. Great. Now we officially have a TypeScript project. Now create the utils, the same module that I had about the validation function with the callback. Create it in TS. Make sure you've deleted the utils.js and DTS. While I was debugging, I spent 20 minutes on trying to understand why it wasn't working. That's because I wrote the utils.ts, but I didn't remove the utils.js and the DTS. All right? So this is what it looks like. It's kind of like a merge of the utils.js and the definition file. I'm importing all the functions that I need from the card validator npm. I define what a validation error looks like, and I define what a callback that uses it looks like, and then I export the actual validate function. I cut out the rest of this. You guys basically understand. It's a function that takes a string, a value as ID, a value as string, and a callback, which is of type validate callback. Then it'll do its work, and then it's going to invoke the callback function with the found errors. Right? Now, I go back to my client code, which is form input, and instead of importing the utils, I'm going to import utils.ts. This may not be necessary anymore. The Babel compilers are updating themselves so that you don't have to maybe add the TS extension. But will it compile? Who says yes? Who says no? All right. Well, it won't, because can't resolve utils in my project. All right, that's correct, because we need to tell Webpack to recognize TypeScript files first. All right, so let's do that. This is what the Webpack looks like. Now it's going to look like this. Cool. I'll let you guys, yeah? Sorry. How about now? Well, it's not going to compile because we don't know how to read TypeScript files yet. We're talking about Babel TypeScript preset, but I didn't show you guys how to add that first. So let's do that. npm install Babel preset TypeScript. It's awesome. And in your Babel RC file or Babel configuration file, you add the Babel TypeScript to the array of presets. How about now? Well, it works. It's awesome. This is Amy Wambach. She's great. All right. Nice. So we have a TypeScript project and it's working, and we have injected some decent TypeScript into our project. But are we getting any TypeScript help, which is compilation errors if we make a mistake? Let's trigger an error and see it. All right. We know that there is this function that comes from the card validator npm, and it's supposed to take value of type string. And what if I just pass a Boolean in there, right? First of all, my IDE knows because it has type definition, and that's powerful enough, right? But what about the compilation? It worked. Why? Because remember, Babel preset TypeScript does not compile, but it rather removes the TypeScript syntax. So if you want strict type security, which is the ultimate TypeScript feature, then you can do one of two things. One, start another shell process and run TSC, which is the TypeScript compiler, and watch your errors there while you're using the Babel presets to bundle. You can use another process to see your compilation errors. Or you can do the ultimate thing, which is the last stage of our how to inject TypeScript into your existing project, which is the TypeScript compiler. This is just writing TS files or definition files, and this is the real deal. So let's take our project that we've worked on step 3 and turn it into an actual TypeScript project. Now, most of the work was done. Currently, we have our Babel configurations look like this. We have the Babel preset TypeScript, and our Webpack looks like that. First thing that we're going to do is relieve Babel of its duties. We don't need Babel for TypeScript anymore. The second thing is we're going to add another loader for Webpack so that it can recognize and compile TypeScript and add it into our bundle. I like Awesome TypeScript Loader. There's also TS Loader. They're both great. The only reason why I preferred Awesome TypeScript Loader so far was that its source maps were a bit better. It was easier to debug, but maybe TS Loader caught up already. I'm really not trying to pick sides here. So now the Webpack configuration looks like this. We're going to take the TypeScript extensions out of the Babel loader, and we're going to put it into another clause that's going to use Awesome TypeScript Loader. So basically, Webpack is going to use the Awesome TypeScript Loader if it comes across a TypeScript file. Great. It's working immediately. I didn't have to do anything. Do we have type security now? As you know, this is what I tried to do. I tried to pass a Boolean into a function that accepts a string, and bam, I get an error immediately. All right. So to recap, don't think of TypeScript as another language. You are using JavaScript in the end, and stick to that, and always bet on JavaScript, just like Kyle Simpson said yesterday. Let's make sure that we understand that this is a toolkit, and we need to use it for our customers, but more so we need to use it for our teammates. We need to use it for the next team to take on this project, or we need to use it so that if we are writing some code that other clients are going to use, other client teams are going to use, we're helping them out by boosting our documentation, by boosting our APIs, by using TypeScript. All right? And if you're sold on this idea and if you want to start using it, there are some levels in which you can do it. There are some things that you can do right now. You can do this right now at the break. Step number 1, install type definitions from NPM for all the libraries that you're using and push that to production. It's fine. This doesn't affect your code anyway. Second thing that you might want to do is maintain definition files for your existing JavaScript modules. And this helps you by making your IDE much more powerful and giving you warnings and errors on things that you may not have caught. Because let's face it, we all go through refactoring. And when you go through refactoring, sometimes you miss things. Third level is using this awesome handy thing from Babel called the Babel TypeScript preset, where you're writing TypeScript, but Babel will transpile that for you by removing the TypeScript syntax. And in the end, if you want to do the real thing, you include a TypeScript compiler in your bundling process, and you have real TypeScript in production. And that's it. Thanks very, very much.